In this video, we're going to continue our introduction to the Arduino by looking at some of the other basic things that we're going to need. So at this point, we have the Arduino software installed, and we were able to run a simple program on it and look at the outputs using the serial monitor. And importantly, what we looked at was some of the very useful functions such as serial.begin, serial.print, serial.println, and delay. And so these are the ones that you're going to use quite a bit when you do this stuff. Okay, but what else do we need? So if you're going to be doing any computer program, you're also going to need to look at things like data types and how the data types are used when you assign them to other variables. And we also got to look at the notion of global and local variables. And then we also want to look at simple math operations, making decisions using if, then, and case statements. And of course we need loops, and there's two really common loops, for and while loops. And we can use loops to enter information into the serial monitor, which is kind of neat. And then finally comments. And then once we get through this, then it's basically looking at just using the Arduino to actually accomplish real tasks. So let's start off by looking at data types. The Arduino supports the common data types that you might think about. You know, int for integer, float, double, char for character, and string. One important thing, string has a capital S. So remember, Arduino is case sensitive when you program. And what's neat about it is that the print function works directly on these. So in addition to being able to print out a message to the serial monitor, you can just say print and then put the variable name in it, and it automatically recognizes what type it is, and then it'll pop it out. And where we define these things, whether it's in the setup or the loop routines, is going to dictate whether it's a local or a global variable. And then additionally, conversions are also possible. So there's a number of they call it casting, when you change something from like a float to an integer, or vice versa. And then so there's functions for that. And then there's also ways to convert strings to integers and strings to float. And this becomes super useful when you read information from the serial monitor. So the serial monitor, if you remember, it's always sending ASCII codes. So if you type the letter, A, it's going to come up as some ASCII code like 50 or something. And what'll happen, I don't know if it's 50, but something like that, and it'll come up, and you can't use that directly as a number. So, a better way of saying it is, if you typed in 3 and sent it up the UART, it would be interpreted as the ASCII code for the symbol 3, not necessarily the number 3. And so you would have to convert it to int in order to use 3 in an operation. So anyway, let's take a look at some examples here of how we use this. So I'm going to fire up a new sketch, and we'll put it right here. And then what we'll do is we've got our void setup and our void loop, which are good. And let's just start off by making some basic variables, and we'll see what happens when we try to print them and do stuff like that. So let's go ahead and do a serial.begin 9600 to set up the serial connection to the Arduino. And then I'm going to go ahead and I'm going to create an int called A, and I'm going to give it a number of 22. Okay, so I just have created an integer, which is variable A. Let's go ahead and make a float, which is going to be B, and a float, remember, is a real number, so I can do something like 3.14. And then just to complete the example, let's do a car, which will be C, and a car is a single symbol, so let's do something like E, so we'll actually assign it the letter E. And then if I want to do a string, this is where, let's call it S1, what we can do is say, I can actually put double quotes and say, I am here. Okay, so we have just now set up 4 variables, and we've assigned them 4 of the most common types that you use in your program. So let's go ahead and see what happens when I try to actually, or let's see how I can actually print these. So what I'm going to do is let's print the value of A to the serial monitor and see what happens. So in Arduino, you can't use a printf. There's not a built-in printf. So what you have to do is, when you do a print, I'm going to do just a regular print, you have to put your message separate from the actual variable value. So for an example, I'm going to do something like this. I'm going to say A is this. And then I'm going to then put another line where I say serial print, and all I do is I just put A in the parentheses, and I'm off and running. So let's go ahead and fire this up. One of the things that asked me is, hey, I need to save this. So let's go ahead and do a file, save as, and I'll come over here to my desktop where I have my Arduino folder, and I'm going to come in here and I'll just go ahead and say activity 3 data types, and we'll go ahead and save that off. Okay, so I'm going to go ahead and run this, and it's going along here. Everything's great. It's going to download it, and then what I need to do is bring up the serial monitor. And here's our serial monitor. So let's go ahead and look at what happened. Okay, so it says A is 22. Great. All right. So notice that I could just print A directly by having serial print. Okay, let's go ahead and do a couple more. So serial print, B. B is, and then I put a space there and do that, and I go serial dot print B, and let's go ahead and do all of them just to kind of show what we're doing here. So then we got C is something, and then we'll go S1 is S1. Okay, so let's save that and see what ends up happening there. Okay, so it popped out and it wasn't very nice because it said A is 22, B is 3.14, C is E, S1 is I am here. Notice that I didn't put line returns in here. If I wanted to put a line return in here, what I could do is I could do it two ways. I could say serial.print, and I could actually do /n, and then that would do a line, or I could actually come in here and change all these to print line, and then that would put it in there. Okay. All right. So let's do that one. Oops. Line. So let's go ahead and run that and see how that looks. Okay, so now it's going to fire off, and boom, there it is. So you see how all these things worked. So this is pretty straightforward, pretty easy. One of the things that's interesting is that I've defined these these variables inside of the setup loop. So if I came down here into the void loop and I said I just want to print out I am here over and over and over. So I'm going to go print ln, and then I'm going to say S1, so I'm going to print my string, and let's take a look at what happens here. So I'm going to go ahead and verify this and compile it, and it errors out. It says S1 was not defined in the scope. What that means is that you defined these variables inside of the setup loop. Well, the loop or the loop scope is what they call it, it can't see inside of here. So this is the concept of a local variable. This variable is local only to the setup routine. So down here, loop can't see it. And that's kind of neat because you can actually have the same variable name. So if I came down here and I said string 1 is equal to not here, and I did something like this, I could say, okay, now I'm going to do this, and I'm going to fire this off. And what I was able to do is I used the same variable name in two different scopes. So in one situation, now it's off and running here, but if I can look back at the top, let's see if I can do it. You can't do it. Let's do this. Let's go delay 1000, and let's go ahead and save that. So now in this situation, what it's going to do is this local variable S1 is I am here, and that'll be printed first, and then so it's I am here, and then down here this is a totally separate variable, separate local variable within the loop scope that is also not here, or is something different. Okay, so two different variables. Anyway, this is the concept of a local versus a global variable. If I wanted a global variable, that means that it is seen absolutely by everything in my code or everything in this program. What I can do is I can come out here, so I can do something like, okay, I'm going to say string S2 is equal to really here. And now I've set that up, and let's go ahead and see if that'll work. Let's verify that first. And so that's gonna set up this new variable, and it's like, okay, life is good. And now let's go down here and let's see if both of them can see it. So I'm going to go ahead and say S2 is, and then print line S2, and then I'm going to do the exact same thing in the loop scope. Okay, so I come down here, I'm going to print this, and if this works, that means that S2 is indeed a global variable. Okay, and then this is an important concept because you can really get confused, and you can really get the wrong results if you don't track where a variable is defined and how it is actually used. Okay, so this now is notice that it's going, I'm here, S2 is really here, not here, so it's like this was the first instantiation of it, and then these are the looping ones. So everything worked out great. Okay, so this is fantastic. Let's look at one last concept, and that is changing data types. So I'm going to come back over here, and I'll go ahead and delete these, and we'll go back up. And we have ints and floats and characters and stuff like that, and this is great. What if I wanted to take b, which is a float, and I wanted to convert it to an integer? Okay. Well, the way that this works is you simply, I'm going to do this. I'm going to go serial.print, and I'm going to say a is, and we're going to print the original value of it, so it'll print out 22. And then I'm going to do the following. I am now going to assign, I'm going to take b, and I'm going to convert it to an integer and stick it into a. And you do this using a cast. Okay, so cast is the term you use when you convert data types to other data types. So what I can do is I can say a is going to equal, and then what I do is I put in parentheses here the type I want to convert the argument to. So if you look at this, what I'm going to do is I'm going to assign b to a, but b is a float, so I have to convert it to an integer, and the way I do it is I just simply put that right there. So I put this parentheses int, and that's the syntax for a cast. So now if I do this again, if I do this print, it should reflect what the new a is. So now if you think about this while I download it, 3.14, the 0.14 can't exist in an integer. Okay, that's a real number. So what it's going to do is it's going to basically chop off any of the decimal or the fractional digits. So notice that this represented a is 22, the integer. This one is now a is 3. So no matter what it is, it'll just chop it off. It doesn't round it or anything like that. It just chops it off. So that's the concept of data types. Is it's got these common ones in there, but you can also define them in the loop or the setup scope, and they will only be seen within those scopes, or you can create a global variable, and then you can convert back and forth using typecasts or actual function calls. Okay, so that becomes very important. So at this point, why don't you do an activity where you pause the video and play around with defining some of these common types and experiment with putting them inside of setup or in loop, and then trying to call them from the other one and seeing how the local variable setup works, and then also try to play around with just defining a global variable that everybody can see.